How do I access the ith column of a NumPy multidimensional array?
With. To access column 0. To access row 0. This is covered in section 1.4, indexing, of the NumPy reference. This is quick, at least in my experience. It's certainly much quicker than accessing each element in a loop.
This command gives you a row vector. If you just want to loop over it, it's fine, but if you want to stack with some other array with dimension 3xn, you will have while. Gives you a column vector, so that you can do concatenate or stack operation. For example,
and if you want to access more than one column at a time, you could do
You could also transpose and return a row.
Although the question has been answered, let me mention some nuances. Let's say you are interested in the first column of the array. As you already know from other answers, to get it in the form of row vector, array of shape 3, you use slicing. To check if an array is a view or a copy of another array, you can do the following. SceneArray.base. Besides the obvious difference between the two, modifying r underscore call 1 underscore view will affect the r, the number of byte steps for traversing each of them is different. See strides and this answer. Why is this important? Imagine that you have a very big array instead of the r. And you want to compute the sum of all the elements of the first column, a underscore call 1 underscore view dot sum or a underscore call 1 underscore copy dot sum. Using the copied version is much faster. This is due to the different number of strides mentioned before. Although it might seem that using column copies is better, it is not always true for the reason that making a copy takes time too and uses more memory. In this case it took me approximately 200 microseconds to create the a underscore call 1 underscore copy. However, if we needed the copy in the first place, or we need to do many different operations on a specific column of the array and we are okay with sacrificing memory for speed, then making a copy is the way to go. In the case we are interested in working mostly with columns, it could be a good idea to create our array in column major, F, order instead of the row major, C, order, which is the default, and then do the slicing as before to get a column without copying it. Now, performing the sum operation, or any other, on a column view is as fast as performing it on a column copy. Finally, let me note that transposing an array and using row slicing is the same as using the column slicing on the original array, because transposing is done by just swapping the shape and the strides of the original array.